All right, so picking up from where we left off in class, we did this example, we finished it up. Now we have x squared over 4 plus y squared over 25 is equal to 1. So here, now the larger number in the denominator is underneath the y squared. So this is going to be more of a vertical ellipse. Again, still no adding or subtracting to the x and y. So your center is at 0, 0. We'll plot that point. Your a is going to be positive or negative 5, counting up and down 5. The arrow is the most important thing to remember. We're going to go up and down 5 squares, 1, 2, 3, 4, 5, down 5. Those are your major vertices. And then your minor vertices are co-vertices. Underneath the x is a 4. We'll take the square root of 4 is 2. We're going left or right 2. Those are the co-vertices. We can then draw in our ellipse. To find the foci, again, you're going to take the big minus the small. A squared minus b squared will equal your c squared. So in this case, we're going to end up with the square root of 21 plus or minus, which I changed it to a decimal just to get an idea how far I need to go plot those points. So here you can see we have to go on the major axis, because if you did count to the right 4.5, you would not be inside the ellipse. So we're going to count up approximately 4.5 up, 4.5 down. There's your foci. Again, if you were asked to find the coordinates without graphing, everything comes from the center. So starting at 0, 0, up or down 5, you change that to the y-axis. You get 0, comma, plus or minus 5. Co-vertices, that was left and right 2. You add and subtract 2 to the x-coordinate of the center. Your foci, the plus or minus square root of 21, again, changing the y-coordinate. So 0, comma, plus or minus the square root of 21. Our next example, this is not in standard form, so we got to get this thing set equal to 1. So the quickest way to do that is just divide everybody by 36. So 9 would go into 36 4 times, so 4 in the denominator. 4 goes into 36 9 times, and you get 1 on the right side. So here again, we'll have a vertical ellipse, the larger numbers underneath the y. Nothing's being added to the x or the y, so that's going to be our centers at 0, 0. Again, counting up and down 3 to your vertices. Smaller number 4 underneath your x squared, counting left and right 2. There's your co-vertices, there's your ellipse. And to find our foci, just like in the previous problem, big minus small. 9 minus 4 is going to be 5. The square root of 5 is approximately 2.24, so just slightly past the 2 squares. That will be the location of your foci. And again, as we did earlier, you can find your coordinates of the vertices, co-vertices, and foci without graphing. Just start with the center, add the 3, and subtract the 3 to the y-coordinate of 0. Co-vertices, add and subtract the 2 to the x-coordinate of the center. And add and subtract the plus or minus square root of 5 to the y-coordinates. Always the same as the major vertices, because the foci, again, are on the major axis. So there's our examples with our center at 0, 0. So let's look now. Here you can see we have a new center. So find the x, change the sign. Find the y, change the sign. We are at 2, 1 for the center. 2 to the right up, 1, plot your center. Largest number 36 is underneath your x, so that means we're going to count left and right 6. 1, 2, 3, 4, 5, 6, plotting that point, and 6 to the left. Smaller 9s underneath the y, we're counting up and down 3. Those are your co-vertices. Then draw in your ellipse. Foci are going to be going left and right, so again, big minus small. So a squared minus b squared, or 36 minus 9, that's given us 27. We'll take the square root of that. That's going to be plus or minus 3 radical 3. If you simplify the square root of 27, the decimal version of the square root of 27 is 5.2. So again, just slightly past 5 will be our foci left and right of the center. And you can still Still find the coordinates of these points without graphing. Everything starts at the center. So now you start with 2, 1. Now here's where we have to be careful. Now your vertices are plus or minus 6 to an x coordinate. Okay, so we're going to have to go 2 plus 6 is 8, comma 1. 2 minus 6 is negative 4, comma 1. You have to write the points out separately. You can't leave it as 2 plus or minus 6, comma 1. All right, you actually have to simplify those values. Co-vertices, we're going to add and subtract 3 to the y-coordinate, which is 1. So 1 plus 3 is 4. 1 minus 3 is negative 2. So we're at 2, 4, and 2, negative 2. X-coordinate didn't change for the co-vertices, just like the y-coordinates didn't change on the vertices. Foci, we'll take that plus or minus 3 radical 3, add that to the x-coordinate of 2. Now here we are going to leave this as 2 plus or minus 3 radical 3 because technically you can't simplify that. So it's okay to leave that in that form, then with your comma 1. All right, next example. We have, again, centered other than the origin. So find the x, change the sign, negative 3. Find the y, change the sign, positive 2. 3 to the left, up 2. Plot that point. Largest number, 25, is underneath the y. That's your a squared. So we're counting up and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4 is underneath the x, so that's left and right 2. Draw in your ellipse, and now your foci are going to be going up or down when we find that value. So again, a squared minus b squared, large minus small, is going to be 21. Square root of 21, again, approximately 4.58. Count up 4.5 squares and down 4.5 squares, there's your foci. And as we did earlier, you can find the coordinates again without graphing. Everything starts at the center. Now the vertices, add and subtract 5 to the y-coordinate. 2 plus 5, 7. 2 minus 5, negative 3. The negative 3 for the x-coordinate doesn't change. You just change the y-coordinates. Co-vertices, add and subtract 2 to the x-coordinate of the center. Negative 3 plus 2 is negative 1. Negative 3 minus 2 is negative 5. Y-coordinate of 2 does not change. Foci have to change the y-coordinate, just like you changed the vertices. So now that's going to be plus or minus the square root of 21 to that 2. And again, you can't simplify that, so we'll just leave it like that in our point form. So for the test, you will have to know how to graph an ellipse. You will also have to know how to complete the square of an ellipse. Just like we completed the square with the circle and we completed the square of the parabola. Now here it's a little different. When you group your x's together and your y's, notice that this x squared has a 1 in front of x squared, so we're good. All right, I subtracted the 9 to the other side, and now I'm going to look at these y's, but we want a 1 in front of that y squared. So we're not going to divide by 9 because there's no 9 attached to the x squared. We are going to factor the 9 out of this trinomial, even though there's nothing there, as the GCF. So that becomes y squared, negative 18 divided by 9 is minus 2y. But on the blank on the right side, that represents the y-coordinate, you're going to multiply it by 9. Because whatever we find for that blank, that 9 has to be multiplied to it. So we're just going to put it over here. All right, so complete our squares. Half of a positive 6 or plus 6 is a plus 3 being squared. That's a 9. Half of negative 1. Half of negative 2 is negative 1. I got ahead of myself there. We're going to square that, and that's a 1. So negative 9, positive 9 cancel. We're left with a 9 over here. So my binomial squared, x plus 3 quantity squared. The two terms that are squared go into the binomial squared. That's that factoring shortcut. Y minus 1 quantity squared. We're not done. We have to have this set equal to 1. So we divide the 9 now over to both sides over here. So nothing to divide the 9 in, so that stays in the denominator. 9 divided by 9, we can leave this as a 1, or you don't have to have a denominator. I personally like to put it there to remind myself I still need to count up and down the square root of 1. So finding my center, find the x, change the sign, -3. Find the y, change the sign, +1. Plot it. X has the bigger number, 9. That's going to go to the right 3 and left 3. 1, 2, 3, 1, 2, 3. Plot your vertices. Underneath the y is your b squared. That's going to be a 1. Up and down 1. We have a skinny ellipse right here. We can still find the foci. Big minus small. A squared minus b squared. 9 minus 1 is 8. Okay, square root of 8 simplifies to 2 radical 2. The decimal version is 2.83, so you will almost be right on top of that vertex there with that point for F. And you may have noticed in the past couple examples, when your foci, notice they're really close to the vertices, it's a skinny ellipse. When your foci are closer to the center, it's more like a circle shape. All right, we can still, again, find those coordinates. If I want to find the coordinates of the vertices, start at the center, take your A, 3 to the left, 3 to the right, change your x coordinates. -3 plus 3 is 0, -3 minus 3 is -6. Same with the co-vertices, the up and down 1, change the y coordinate, 1 plus 1, 2, 1 minus 1, 0. Don't change the x coordinates. And again, for the foci, change the x on the center with a plus or minus 2 radical 2, and we'll leave that as 1 point with a plus or minus in there. All right, finding the equation of the ellipse. The center is at 0, 0. The focus is at 3, 0. The vertex is at 5, 0. So here there's no h and k because the center is at 0, 0. So again, I would make a rough draft. There's the center. If the focus is at 3, 0, then there has to be a focus at -3, 0, just opposite of it. If there's a vertex at 5, there's got to be a vertex at -5 on your x-axis. So your C is going to be the value of the center to the focus, so that's a 3, and your A is going to be center to 5, the vertex. So we have this horizontal ellipse where we can now take our general format of the equations, plug in the A. We don't know B yet, but we'll use the Pythagorean theorem with the minus sign to help us find B squared. So we'll plug in the values. 5 goes in for A, 3 goes in for C. We're going to solve this for B squared. So 25 minus B squared equals 9. Add the B squared over, subtract the 9 to the left. 25 minus 9 is 16, and you don't need the 4, you just need B squared to be 16, and your A squared to be 25. There's the equation of your ellipse. All right, next one, the foci at 0 plus or minus 2 and a major axis of 8. So again, we're going to draw a rough graph. So 0, 2, 0, -2. So because the foci are going up and down, this is now a vertical ellipse, and halfway between the foci has to be your center. So that's our C value right there. Our vertices, remember that the major axis is equal to 2a, so we solve that, divide over the 2 to get 4. So that's 4 up and 4 down, so this is giving me a vertical ellipse. I have the A, I have the C value of 2. Again, we'll start with our equation, but we'll put the A squared under the Y squared this time because it's vertical, and B squared underneath the X squared. Still use the Pythagorean theorem with the minus sign. Let's go find our B squared. So 4 squared minus B squared equals 2 squared. Make the substitution. All right, 16 minus B squared equals 4. Subtract over the 4, add the B squared to the right. B squared is 12. We have everything we need. x squared over b squared, 12, plus y squared over a squared, which was 16, put a 16 there, equal to 1, and there's the equation of your ellipse. All right, next example, the vertices. All right, here we go. The vertices are at 7, negative 2, negative 3, negative 2, and the focus is at 4, negative 2. So we're going to draw a rough picture here. Plot those vertice points. Now notice how the x-coordinates are changing, so that means the center is somewhere in between here. So take the average of your x-coordinates. Negative 3 plus 7 is 4, divided by 2 is 2. So our center is right here at 2, negative 2. That's your h and k right now. We're not having an origin as our center. Your focus is at 4, negative 2. Okay, maybe right about here. So for your a value, the 7 minus the 2 to the center, that's 5. 4 minus 2, the change in those x's, is 2. So now we're going to set up what does our equation look like for a horizontal ellipse. We're going to have the a squared underneath the x minus h squared with the b squared underneath the y minus k squared. We're still going to plug in all of our values. H is 2, k is minus 2, which becomes minus and negative, so plus 2. A is 5, plug that in at the bottom, that's going to be 25. Now we got to find b squared, and we're going to find that through the Pythagorean theorem. So again, 25 minus b squared is equal to 4. Subtract the 4, add over the b squared, we're going to get 21. And we'll just put 21 in the denominator underneath the y plus 2 squared, and there's our equation. All right, next example, vertices at 2, 5, 2, negative 1, and c is equal to 2. Again, we draw a rough graph. 2, 5, that's up here. 2, negative 1 down here. So since the y-coordinates are changing, this is going to be more of a vertical ellipse. Your center is going to be right there in the middle. So again, 5 plus negative 1 is 4, divided by 2 is 2. So there's your center. That's your h and k. So 5 minus 2, that's 3. That's your a value. And you have your c value of 2. And we know it's a vertical ellipse, as we said earlier. So now the a squared is going to be underneath the y minus k squared in your equation. Still going to use your Pythagorean theorem to find b squared, which happens like 99.9% of the time. So plug in your center, so x minus 2, y minus 2. Plug in your a, 3. That's going to make this a 9. And then we'll just find our b squared by using the Pythagorean theorem. 9 minus b squared is equal to 4. Subtract the 4, add over the b squared. That's going to give us a 5. So underneath the x minus 2, we have 5. Underneath the y minus 2 squared, we have the 9. And there's our equation. All right, last example. Center is at 1, 2. Focus is at 4, 2. And contains the point 1, 3. So plot points. 1, 2, there's my center. 4, 2, there's my focus. 1, 3 is right above, so that's going to be a covertex. All right, so C, 4 minus 1 is going to be 3. Here we have the distance B from 3 to 2, so we have a B value of 1. So here's the one particular case where we'll have to find a squared, not b squared. So because the foci went to the right of the center, this is going to be more of a horizontal ellipse. So that's going to put the a squared underneath the x minus h squared. All right, so we have the b, so there's going to be a 1 underneath my y minus k. Use the Pythagorean theorem with the minus sign to find your a squared. So a squared minus 1 equals 9. Add over the 1, make it a 10. We'll put 10 underneath the x minus 1. And you have your ellipse. Now, like I said earlier, you don't have to put the 1 in the denominator. It's not necessary. But if you're like me and like to have the two fractions, knowing that you're working with an ellipse,